You light our homes. Keep us warm.
You help us explore, innovate, and achieve the unthinkable.
You are everywhere.
Yet, sometimes out of reach.
You move us forward and bring us together.
And together, we're on a journey towards the future of energy.
So what will it look like?
It's hard to say, but we know it will be sustainable and abundant.
We're already on our way.
With a common purpose, each of us playing our part.
At Deloitte, we're connecting every bright mind, every organization, every startup, every innovator.
Every citizen, CEO, and regulator.
Making this future happen won't be easy, so we're developing practical solutions.
And a clear roadmap to help our clients on their way.
We'll keep making those connections
Each step well planned, moving forward together.
to make our new energy future a reality. Let's connect for a new energy future.
Good afternoon. I've planned to present our guests, but that's already been done for me. Thank you. Well, I'd like to invite you to a trip along the hydrogen chain. We will visit 2 installations in 2 cities in Poland. We'll talk about basic operations in nodes. We'll also take a look at accidents and industrial breakdowns connected with presence of hydrogen in hydrogen supply chain. Also talk about safety and security measures. Our guides on this trip will be already introduced by a colleague panelist sitting here with me. Chain parts of the hydrogen chain. The hydrogen chain is made of a number of links according to this schematic: production, cleaning, storage, distribution, and transport. And these are the elements of today's panel. Our voyage, our trip will start with production and cleaning, purification of hydrogen. So let's take a look at Police. Mateusz, I'm very happy how the process of production and purification of hydrogen takes place. What are the threats associated with the process and how you identify them? Thank you very much for this question. In order to answer, I think I'll make use of the materials I have. You could take a look at the slide. It presents in a brief manner the entire nature of the polymer Police project. It all starts in the newly built terminal where we take in propane and ethylene in cryogenic form. Then we send it to installations dehydrogenizing propane. And today I'll tell you more about this installation, since hydrogen is created as a side product here. And it can be said that our company is conducting this entire production chain until polypropylene is produced. We produce 70,000 tons of hydrogen a year. This is what our project looks like. August 2022, PDH installation. You can see that the construction phase is nearly finished. A view from the other side. This is where the heart of the entire process lies. What we see, it's a section of the reactor in which the chemical reaction of propane takes place. It's endothermic reaction, so you need heat. That's why we can clearly see technological ovens here, furnaces, technological furnaces, installation from a different perspective. Once again, we see the reactor, the furnaces, catalyzer section. And the main goal here is to produce propylene. However, hydrogen is a side product. Currently, we're using hydrogen by sending it for synthesizing ammonium in the Police chemical plant nearby. The technological processes at the PDH station deal with separation of the product and the side product and hydrogen. What's important about hydrogen? Well, we see the installation, or actually a PSA section, that is purification of hydrogen by absorption, pressure-based absorption. You can see the 6 absorbers. A view from the other side. You can see not just the absorbers here, but also all the piping, the entire installation, which is directly connected to the section. Compressor, which compresses the hydrogen gas, which goes to the PSA installation. And through the installation, we obtain pure hydrogen. Of course, pure is relative here. For us, it's very pure. The main principle here is that we go through absorption of impurities, and later the absorption fields are purified, and we get two streams, a stream of clean hydrogen, and on the other side remaining pollution, and we use these gases in our installation as heating gas. So now we can move on to the part connected mostly with safety. And here I'd like to present to you two ideas which deal directly with the question asked by Aleksandra, that is safety, how we approach safety. In brief, we could say that we have two main approaches which are interconnected. First is so-called rule-based approach, standard-based approach. Here we use all the standards which deal with safety, starting with the SES directive, ATEX, PD directive, fire safety regulations. As far as Polish norm standards and foreign regulations, we also have conclusions here from historical processes and literature. Now, all these sets of information have certain rules which have already been prepared based on experience, and they affect our processes as far as planning, that is the design process itself, as well as the second very important phase, which is not seen very well, the phase connected with the functioning of organization, the functioning of people. Everybody knows that safety is closely connected with operation. Second point, we are not able to cover all individual configurations of the plant, all the individual aspects, despite the fact that we're using the installations where you have hundreds of such examples throughout the world. We are amending this approach with risk assessment, so it's essential to realize that safety requires not just fulfilling the minimum requirements, minimum regulations, which are not always in line with cost assessment. However, in our case, this approach connected with standards has also been amended by highly assessed risk analysis. I'd like to present three parallel pathways which have proven themselves to work. Of course, there are many ways we can follow here, many methods, but the one we've used is a compromise between the time that is needed, because we know that the risk analysis are time-consuming and costs also matter. So the three streams, the first stream, as far as analysis, it's hazard-based analysis, hazard identification, identifying hazards, risks, which is carried out at the very early phase. We identified all the hazards and are able to direct further analysis. So they give us background for further analysis. As far as HAZOP analysis, this is a well-known analysis these days. It's already part of the main stream as far as investments. In HAZOP analysis, we create scenarios, so we have particular phases of safety procedures. As far as any potential deviation connected with improper use or functioning of installation is identified, and thanks to that we are able to identify diversities, provides wonderful material for designer or even such people as myself who manage safety at the operational level, where we see our barriers, because key issue here is assigning to each thread or cause a certain safety mechanism, and we have a certain set of mechanisms of barriers we can manage. In parallel to it, we have a quantitative risk analysis pathway where we conduct analysis of consequences of results, which gives us a certain guidelines to the construction, architectural design, and this is supplemented later with further qualitative risk analysis, QRA, and we can use it to plan certain safety, rescue operations. It allows us to study quite closely all possible situations, scenarios which can take place due to lack of sealing. And the final procedure is the explosive risk assessment analysis. This is also obligatory. Well, this should be started at a very early stage of the project when we talk about subcontracting, etc. Of course, now we have extended supply chains, delivery times, which has impact on investment decisions. And another point connected with it, assessing the of explosions, explosion risk assessment, standard ERA. The most important, as I've said before, the most important thing is to start as early as possible on these. So these very briefly, very quickly, these are the main principles that we follow. So we've gone through the production and purification. We are continuing. Now we are going to visit storage facility, hydrogen storage facility in Trzebinie and newly open installation, ORLEN South S.A. Paulina, I'm very interested in storage principles in your installation, working parameters, and also the safety measures that you've used in your storage. Can you share with us some details? Yes, of course. Good afternoon. I think my colleague told us beautifully, very eloquently about all the analysis connected with the design during design stage. On myself, I would like to deal more with practical approach, how such safety solutions look like in our case. Despite the fact that my colleague here has mentioned the entire production process, told us about it. However, I would like to also show you, in order to show you that the safety mechanism we have, I'd like to tell you first what this installation looks like and share with you knowledge about particular nodes. On the picture, you can see the installation is divided into 4 sections. The first section is extra purification node, the same as in Police, the module. Then we have a compression module, then storage module, storage node, and loading module. The main goal here is to produce hydrogen of automotive quality. If we are talking about this type of production, I think one of the threats here that we have in this installation, these are compressors, due to the fact that in order to obtain hydrogen of automotive quality and to effectively transport it to hydrogen fueling stations, we have to compress it. And compressed hydrogen, this is 400 bars that it's compressed to. So we have relatively high pressure in the installation right away. We use membrane compressors here. The pressure, as you can see on the slide, is 405 bars. Due to process reasons and also to protect us from possible breakdown in this unit of a compressor that would stop the process, we've doubled the system. So if we do have a breakdown, we can use the second one. So once we have compressed hydrogen, the next section is the storage node, storage module. One might say this is the most hazardous, the most dangerous node we have, because here we have a lot of hydrogen, about 1,300 kilograms, and a high pressure, 405 bars, and a lot of connections between these tanks, because as you can see on the picture, these are these sort of horizontal tanks that are interconnected, and there are 18 of them in total. They're divided into 3 sections. One might say it's that we have generally low section, mid pressure section, low pressure section, mid pressure section, high pressure section. As you can see on the diagram, they are placed in a specific protective wall. The wall creates a certain barrier, certain protection. So in case of an accident, a potential explosion, the wall is meant to protect the infrastructure which is created all around. That is buildings and other tanks which store other substances needed for different processes.
So it is a certain barrier. I think it is also worth mentioning that in the case of a leak in such a container or a crack in it, as various things may happen, this wall can also constitute a barrier for such a stream of hydrogen under high pressure. Again, it's 400 over 400 bar. It could be a threat to those walking about the plant and also to the buildings surrounding it. We all remember that hydrogen is light, so it goes up, so the stream is directed upwards. That's true, but at the moment when the leakage or crack of the container occurs on its side, in the very first moment what we get is quite a strong stream that could hit a person passing by. That is why the wall is this barrier that would safeguard the person. The stream would hit the wall and change its direction. I think that also at this point it is worth emphasizing that hydrogen has low activation energy, which means that it needs only a small spark to ignite, and then we have a fire of the stream, which is quite a dangerous occurrence. In order to eliminate ignition sources on our system, we obviously have well-suited pieces of equipment, those intended for explosive threat zone. The employees are wearing electrostatic garments, we've got the grounding, and we've got the lightning protection systems installed. I mentioned that the pieces of equipment are well suited to the potential explosion zone, owing to the fact that the tanks are surrounded with a wall. We also increase the zone. So we've got the first zone of explosion risk at the containers, and at any other node we've got zone 2. So using certain safeguarding measures, we can increase the area of the zone, and we need to pay special care and remember about the hazard. Thinking about designing the compressors, we decided not to put them under any roofs, and that is in order to avoid the accumulation of hydrogen, as potentially such accumulation could lead to increasing the threat of ignition and causing threat to the employees. When speaking about safety measures, yet another portions of those are hydrogen detectors and flame detectors. I think that you would find such pieces of equipment at any systems resembling those of ours. Their task, even before alerting the workers, is that they need to inform that there might be some higher concentration of hydrogen, which could potentially mean that there is a leak, and that leak could be dangerous. Such hydrogen detectors inform about the concentration that is far below the lower limit of the explosion threshold. The first alert goes off at 20% of the lower limit, and the next one is 40% of the lower limit. Those detectors have a sound and visual signaling systems to them, so if somebody is around them, is informed with sound and also the light that there is a potential threat. The system is also equipped with CCTV cameras, so the controllers in the switchboard in the main room have control. They monitor the area, and they can also always check whether anything potentially dangerous is not happening. These are high-resolution cameras. They also have infrared, Owing to that, we are in a position to spot any flame of hydrogen quicker. As for the process that is carried out, it is quite well automated. And this is done so as to eliminate the human error in as much as possible. Because I think that this is always the greatest risk. So in terms of the control of the process, it is realized in the following way. Where we've got the loading and the pressure drops in the containers, a signal is sent to the DCS system that we should launch and activate the compressors. If DCS gives consent, compressors are activated, and the storage nodes are filled. In order to safeguard the reloading of storage containers, the process is automated, as I mentioned. So first one section opens, and when the pressure converter shows that pressure at a given section is right, then it closes the cutoff valve, and then another cutoff valve is open at another section, compressors load another section, and again, if we have a pressure converter signal that this section has already been filled, we switch on to the last section. And if it turns out that the last section, the last one is filled to 405 bars, we have the signal that this level of pressure has been reached, that the signal is sent to DCS that the compressor should be switched off. If it so happens that the compressor is not switched off and the pressure rises in the containers, in the tanks, then what happens is a complete cut-off, and we treat this situation on the valves as emergent situation, and the installation moves to the manual mode from the automatic mode, and the operators need to verify the root cause and eliminate it if there was any failure, or simply cancel the error signal. And I think that's all in terms of the protective measures that we have at the storage node. So I give the floor to another speaker. Thank you very much for sharing this interesting, rich knowledge. We've seen the production and storage, both in Azoty Polyolefins and in ORLEN Południe, ORLEN South. There are very restrictive safety-related procedures, as confirmed by the speakers. We can see that hydrogen economy is developing in Poland. Completely new investments are planned, including investments concerning hydrogen infrastructure. The amount of compressed gas in those installations can vary from a few hundred kilograms to several tons. So now, Zdzisław, I will address a question to you. I've been wondering for quite some time now about the issues concerning the Seveso directive and the limits for hydrogen set in this directive. Let's move back now to Gdynia. So we now travel from Trzebinia back to Gdynia. Is it possible to place a 7-ton of hydrogen fueling station and storage station in the middle of the city? Let's also look back and analyze some failures in which hydrogen was involved, and also the protection measures in increased risk work sites. Thank you very much, Aleksandra. I like the first question very much. So a classic, or can you actually place a station for 7 tons of hydrogen in the middle of a city? It's a very provoking question. We talk at a rather high level of generality. We talked about some standard plans, so those places where you have a professional staff. There are services that are responsible for designing and verifying everything. We've also seen the approach to risk analysis until the moment of the generation of the product. But we are talking about industrial areas. But Seveso mostly relates to those very areas, to those industrial areas that are historically related to industrial failures, but it also points at certain thresholds. You probably know these limits very well, so certain thresholds concerning the work sites of increased risk and high risk. So the first threshold is 5 tons. So 5 tons up, a plant becomes an increased risk plant. Now, this question is provocative, because when we talk about producing of hydrogen and storing it, So we have, say, generation, and right next to this generation point, we store it, and these are industrial areas. But when we talk about a mobile station or a fuel station as such, that would replace a typical fuel station in the future, the one that offers us LPG, LNG, CNG, or petrol, when we come across a certain issue, because if we take into account the 5 tons following Seveso Directive and implement it to our Polish conditions, so the Act on Environmental Protection, the 5 tons, well, this is not much. Earlier on, we heard that the storage was 1.3 tons of hydrogen, but if you look at it from the point of view of how we would like to fill up a certain passenger's vehicle or a bus, the 5 tons for such a typical station, let's say for buses that would have, say, a few buses, or say, I don't know, 50, 70 kilograms is what a single bus needs to take a ride for a day, which means that 5 tons, that would be just a regular station for the distribution of hydrogen. So we can call it an increased risk work site. So can we build it or not? I'm here because you need firemen here. If we do not put our stamp underneath, if we do not accept such a structure, then of course nothing will be constructed. I'm laughing here because today, if we only rely on the Seveso Directive and the Environment Protection Act that refer to industrial facilities, we can say that the 7-ton station cannot be simply erected in the city center because it is closely related. So those industrial areas are clearly connected to the zoning. So if in the zoning plan there is no provision of using a particular area for industrial purposes, then there is no option, because actually you would have to update the zoning plan. The zoning plan plus Environmental Protection Act identifies certain distances between the station and some facilities around it. So another issue offers itself. There is an item 70-something in the Act that tells you about safe distance, and that there will be some executive act on how to actually define them. But since 2016, well, the Act has changed. The directive was implemented, but this executive act has not been passed. There are others who have been here, who worked on the bill, but there are no urban planners who would only see a table. Like, give me a table, 510, 150 meters, and this is not the way to go. You cannot do it this way. So if it was possible to surmount this first planning-related problem, and somebody said, okay, we will change the zoning plan. Another issue is those safe distances. But let's say that we have a fireman, some expert who, as we say, based on his technical knowledge, prepares a certain expert's opinion, signs underneath, put a stamp on it. Of course, given his experts or technical knowledge, or her experts or technical knowledge, I think what they should do is implement the process safety-related approach for such a hydrogen filling up station, fuel station. Then a separate issue will be, okay, how to construct it. Let's say that we've got this authorization. If it is to be surrounded by regular municipal buildings, typical fuel stations, we've been there, okay, they have some underground tanks that have hundreds of cubic meters, and that raises no concerns. We all know about the threats connected with fuel, but of course, we can see some cars exploding in American films and so on. The threats are not that big. With LPG, we were through this process some time ago. LPG in Poland has increased in terms of its popularity. LNG appeared not directly as a typical distribution station, so not as fuel for vehicles. This is something rather that you would have for larger fleets of cars, but they appeared as regasification local stations where you have no gas pipelines, you can build them. So we've got those 5 tons here. There is a lower threshold for LNG, so everything is done not to exceed this threshold. So a fireman has signed underneath. Firemen go to some other event and they see some structure erected, 2 big LNG tanks of some tons. If something like that was supposed to happen in the city center, the question should be asked how to do it so that it is safe. One approach would be, for example, to build a bunker open from the top. Hydrogen is lighter, so it will move up should there be any emergency release situation, leakage situation. But there is also this distributing machine, so a staff member needs to know how to use it. There are some safety measures. What should happen if somebody doesn't, for example, take it out of the car after tanking and leaves? So there has to be some cutoff mechanism. So there are some effects that, well, it is possible that the typical fuel station, LPG station, will be there, and we'll simply add this third component to it, adding hydrogen to it. Will it all fit in, and will there not be any negative interrelations between those different fuels? So how to place it? What distance should be kept in relation to the existing infrastructure? You cannot give a straightforward answer to this question, this provocative question, because there are too many questions and too few clear answers. Here, during the break, I talked to some of you, and if you ask me, okay, so what do the firefighters have to say about that? Well, as of today, we are only beginning to come across these issues. We do not have clear legal provisions concerning hydrogen fuel stations. The first ones will be probably below the 5-ton threshold. It is not as popular a solution. There is no as developed a infrastructure or the fleet of cars so as to have big demand. But in a few years, I'm sure, comparing what has happened with LPG or LNG to what we have now, with response to regasification local stations popping up here and there, I think that we as planners, firefighters, or those who simply come to control it fire safety-wise, we will surely come across these issues. But now, speaking as an expert on fire protection, what we have to rely on is our technical knowledge. So after going through this first obstacle, so having the right area taken into account in the zoning plan, what is left is the standards that are applied in the world, an HPH or is ISO, or the solutions then that we simply absorb from some other countries. We are lagging a step behind, so we can learn, we can make the most of those good practices, and that's the only solution that we can actually adopt, as it seems. But the history shows that when a problem starts to become a bit bigger, our legislative forces will decide to offer some legal provisions. And I'm not talking only about our national legislation, but also EU-wide legislation. The 5 tons will be too little for a typical hydrogen fuel station, as it will not make up for the demand of all kinds of cars, starting from passenger cars through vans and lorries. Such a fuel station has to be available 24 hours a day, and you cannot have some kind of battery car or a car that would come to the station twice a day. This issue will have to be resolved at a higher level somehow, and what we have today is the technical knowledge, international global solutions, norms, standards, and this problem is something that we start seeing as firefighters. That is why I'm here. We have not had that many events concerning hydrogen in Poland, but in hydrogen transport, when we talk about vehicles transporting them, we've had, let's say, 5 events of that kind over the period of 10 years. I looked into our database, so we didn't have more than 5 events or incidents concerning hydrogen. But if I compared it to the situation in LNG transport, when in 2001 we had first exercise to teach firefighters about the cistern or about LNG fueled car, there were 27 auto cisterns registered in Poland. Now we have the number reaching 1,000. Nobody knew what LNG incidents were because they were non-existent in transport statistics. But As of today, we've got between 50 and 100 incidents over the last few years. So you can see the increase in the number of incidents, and the same goes for on-site trailers transporting hydrogen. It's likely that, again, the number of incidents will start rising the more of those we have. So I'm here right at the onset of it all. I participate in hydrogen-related events so as to initiate a conversation about it in relation with firefighting teams, so that we can cooperate with the hydrogen industry representatives, and we can maybe offer some suggestions of how to solve certain issues. I understand that there is a different approach represented by industry and a different one represented by fighters. So firefighters would come and say 200 meters, a zone, have sprinklers. If there is something else nearby, then removing of the flame, and let's have sensors, at least one per every square meter. But the industry will say, come on, come on, come on. If I'm supposed to do it, okay, I got it. It has to be safe, but I'm calculating investments, calculating money. If the return on this investment is 100 years, this infrastructure will have become old by then. So we'll need to reach a certain golden means here, a certain balance. And so there is no simple answer to your question of whether it can be done. Anything can be done, but provided that certain conditions are met. And our experience as of today, when we talk about hydrogen, this is something that we've learned not by participating in some direct participation in some real events, but owing to the fact that we, as firefighting services, also need to approve some operational firefighting reports from the companies, and we also control the work sites of increased and high risk. And those basic actions that should be taken when there are, let's say, local in-house firefighters, well, they are knowledgeable about that. So our local firefighters have this knowledge because they know what is going on in the area. And from my point of view, what matters for firefighters is education. Education and the problem of emergency events, what to do should anything happen. The first firefighter who comes, he will not necessarily notice that something wrong is going on. Because as you can see here, the American chamber responsible for chemical industry shows you the propane, butane, and hydrogen fire. Of course, there is no carbon, so you see only high vapor impacting the flow of air. It's higher than a sauna, it could burn you down, but the firefighter will not see it visually. He will not be able to notice that actually there is a fire going on. But if you have an infrared camera, a very simple tool that we all have at any firefighting car, out of 500 cars that we have, you have infrared cameras in any of those. So the education, telling firefighters, come on, use it, such an occurrence can happen, is very important. Now we simply have too few of such events for everybody to be aware. We do not have experience yet. I could go on and on. I'm being shown the clock, but summing up this short intervention, lack of legal provisions. So first of all, we should rely on technical knowledge and good standards from other countries, and looking at the limit of 5 tons, because later on we as firefighters will not forgive. Thank you very much. Ladies and gentlemen, we will go back now to Police for a while. And again, we'll have a look at the production node, but from a different perspective. Mateusz, you very eagerly share your knowledge and expertise. Could you show us what preventive measures are applied at your systems? I'm talking here about technical and organizational safeguarding protective measures. Thank you very much for this question.
Well, I'd like to say that as far as prevention practice, regarding these organizational technical solutions, first of all, we have to say that it's very complex. It's all very complex as the first point, and the second point is that due to this certain individual character of these investments, I'd like to refer to something I've said before, that is about processes based on standards and risk assessments that I've sketched out. And sticking to those is half of the success. Because if we have identified various risks, if conducted various analysis, it still leaves quite a bit of way to go in order to really ensure safety. However, it's probably most important how these individual layers should cooperate with each other. If they are in total to provide us with an appropriate level of safety of people and the environment, then it could be systemized during a model which is widely used, which allows us to systemize the entire process also when it comes to training issues. That's first point. And the second point, it also allows us to make up for the individual character, because if these layers are interconnected, then obviously gradually the likelihood of something not working is increasing if they work in connection. So by proper identification, we have the initial conditions to manage something. In other words, it's measurable. We can create a certain causal chains here, and in such a model we have three models: that is prevention, protection, countermeasures, and various technical organizational measures taken can be attached to various layers. Now, if we are talking about various threats connected with hydrogen, or this low minimum temperature of ignition, or stream-like fires connected with lack of visibility in spectrum of light visible to human eye, first of all, then we concentrate on prevention, that is not having such an event take place. Second point, if it does take place, we try to protect what's essential for us, and here we have a strong role of those who manage the facility, because here, in accordance with law, there is a lot of responsibility on their shoulders when it comes to setting safety standards. Every company sets appropriate level of safety. Now, what is appropriate? Well, here we refer to this attempt of trying to assess a certain level of risk, what level of risks is acceptable to us. And the third layer, countermeasure. So if you're not able to protect what's important to us, how are we able to alleviate consequences of negative events? Now, coming from this general statements to detailed issues, I can use the example of how we approach the subject. I've already heard some of these points I wanted to mention, which is great, since we can see that these approaches are concurrent. First of all, there is this principle of not breaking down an open door. Let me put it this way. So we are using already well-known solutions, processes, American licenses, and so on. So here we have limiting of human error using certain systems, control systems, which are obviously not foolproof, but nevertheless, automatization does help us. We introduce alarms, we train our operators, our personnel, how to respond to alarms. And sometimes, of course, there are such situations when human action is not sufficient. So we know right away that it's not possible to react for a human. We have these, one might say, individual functions which have been analyzed, which in a way, regardless of human action, can bring the threat to a safe level and alleviate risks. As far as organization, we can talk about the entire system of managing safety processes. So we are talking about a company where there are no specific requirements regarding process safety, sort of these below threshold companies. There, any sort of decisions of vital nature should be methodically, systematically used as far as the layers of protection. Putting it briefly, the most important aspect for hydrogen, I'd like to point to the second position. The technical measures, ATEX, everything connected with sources of ignition, that's already been mentioned, a very low minimum temperature of ignition, especially when we are talking about investments, if we are using automated systems, etc. We have thousands of pieces of equipment there. So the most important thing is to simply keep an eye on it. The way it is in industry, in sales marketing, 80-90% is a great idea, right? But in industry, as far as safety, there's only one good solution, 100%. So in our case, only one or two devices which are not properly maintained, unfortunate situation, bad timing, and we have a tragedy, right? So we need to be very methodological, we need to be very careful, we need to have proper certificates, install devices in proper way. Another issue of systems of detection, of detecting gas, which has already been mentioned. Fire safety signalization, infrared detection. And here we're coming back to the human factor, because if there is no proper awareness, or if there is a lack of certain procedures, a human can even unwillingly bring in sources of ignition. Let's say, during a technical visit, a person approaches installation and let's say they're improperly dressed and it can create ignition. Also using thermovisual camera by operators. This is also good because it's a good solution that allows us to monitor a large area as far as installation, so it's not just point-based detection. And the last layer, one might say, fire safety systems that we do know. We don't want to, preferably we want to prevent events from happening. We want to maintain safety of neighboring elements of installations. In my view, what's most important here is cooperation between industrial plants and fire department. Personally, I think in terms of distances, we are the closest to the company fire brigade with which we cooperate on daily basis. We talk about plans, about how we're going to react to various events. That's obviously very important. And cooperation with national fire department, state fire department. We have the same goal after all. So here I'd like to encourage you to be very open in contact so that together these solutions can be implemented. So as you can see, it's a very complex process, very complicated one. And it's definitely worth systemizing because this gives us a guarantee. This tedious process gives us a guarantee of reaching 100% of effectiveness. Thank you very much. Hey, ladies and gentlemen, we have gone through production and storage. The next node is distribution. So let's move to Tribune again. Paulina, I wonder about the way and distribution in your installation. And please, if you could also tell us a little bit about the vehicle that you're using to transport hydrogen. Of course, thank you very much for the question. As I've mentioned, the process is quite heavily automated. so that we can avoid human error as far as the loading terminal. Here, unfortunately, the operator does have to take some steps, for example, attaching the hose, but as far as the terminal itself, here we also have hydrogen detection and camera that you can see on the photos. But the process itself, hydrogen loading process itself, is controlled by certain automated logics. The process needs to be ready. What does it mean? Well, it means that certain conditions must be met. There's no fire, lack of detection of hydrogen, DCS system agreement, also proper functioning of sensors, and the system being sealed. If one of these elements is not met, the operator cannot move to the next step, that is to fueling. Now, if all these elements are met, the operator simply pushes on his panel the action button and he can move to further steps. The next step is connecting the gas container or another vehicle to grounding. If the system detects that such grounding has been connected, then it allows us to go to the next step. If the system detects that grounding is not proper, it will not allow it to go, and there is no possibility of further steps. If all is okay, however, the operator moves on, and the next step here is connecting the hose to the vehicle. And after conducting this operation, the operator must confirm on the panel, the operator's panel, that it's already done. And then sealing test takes place. It is conducted in this way that the pressure processor, after 10 seconds, checks the given pressure on the hose, and 10 seconds later checks it again. And if delta P is lower or equal to half a bar, then that means the system is sealed. That is, we can go to the next step. However, so if it's positive, the operator can start fueling, pushes the button, the valves are open, and the vehicle is fueled, is loaded. However, if the test is negative, that is delta P is greater than 0.5 bar, then we have to go back to step 1, that's the system kicks us out, so to speak, and we have to start the procedure again, including disconnecting the hose and connecting it again, because there is a possibility that connection was not right, and there is some leak on that connection point. As far as the fueling process, I think it's well thought out, and there is no threat here. Maybe 2 words about the container which we have. The container which we use is an MGC container. It's a container for transport of gases. We fill it with hydrogen in the pressure of 300 bar. As it was already mentioned, in our stationary tanks we have 400 bars. So here we are using differences in pressure. Hydrogen in the amount of 400 kilograms, and in this vehicle we bring the hydrogen to the station in Krakow, where we have a fueling station for city buses. We have 2 hydrogen powered buses in Krakow which are fueled from this container. As far as installations in our place, I think one of the safety measures, and it's quite clearly seen on this picture, is a sprinkler. It's a fire sprinkler. Fire department station is quite near, so if we do have a breakdown, we have the fire sprinkler either on the container or on our stationary spreading water on container or on our stationary tanks. The decision whether the containers are going to be cooled or fire put down is taken by the fire department, our fire department. As far as the fueling system, that's about all as far as safety mechanisms. Thank you very much. So we're staying with the last part of our chain. You mentioned MGSC vehicle. Zdzisław, last question, which I've prepared. Let's take a look at the transport procedures. When such a fuel trailer leaves the terminal and enters traffic, we can't forget about ADR, traffic regulations connected with transport of hazardous substances. Can you tell us more about it? Let's take a look also at accidents with the participation of hydrogen trailers.
From the point of view of ADR transport itself, as a firefighter, I have no concerns about the safety of ADR transport. Over the last 20 years, ever since I was in service, globally the quality, so the technical state of the vehicles, has not risen any concerns. There are some isolated cases where something is wrong, but the number of those incidents in ADR does not exceed 5 a year in Poland. And that also stems from the fact that if we took such a transport and thought about how many kilometers it covers a year, it is low. So the number of incidents is low. ADR agreement has to be, requirements have to be fulfilled. Poland is part of the agreement. There are some limits concerning hydrogen, the carrier itself, and it being a storage. So you can see here in the picture just an example. There are many different kinds and means of transport, but what is important from my point of view is the potential for accidents. Of course, single accidents did take place, but from the point of view of a firefighter, it is important of whether there has been leakage. If so, how to verify that. If there was ignition, then the question is whether we can identify this ignition. And what is important is also emergency reloading. When we talk about global systems carrying all sorts of liquids, whether they are flammable, we can handle them. If we talk about LPG ones or LNG ones, we know the infrastructure, we know the fittings, we know how it is structured. We've been through that in practice many times. We've reloaded, unloaded it in emergency circumstances. But with hydrogen, well, as of today, this is a topic that requires some further inquiry. Is very there are only very few people who have this background in technology or chemistry that have been in touch with chemical engineering or increased risk work sites. So these people know. And it is only those in-house firefighting units that have practical hands-on knowledge concerning the safety issues about the vehicles and also about stationary containers that appear in the context of fuel stations for it. Another element that is also important, and I pointed at it, we cannot see the fire, we cannot see hydrogen burning, but we can detect it using, for example, a thermovisual camera. There are also detectors on the first firefighting car. They can also go off when there is this presence of flammable substance burning, but they will behave somewhat untypically. The presence of hydrogen in the entire set of sensors will cause one show a plus value, another one will show a display saying that we have a negative concentration, but at least you can use this information for firefighters to be sure that this is about hydrogen appearing in the atmosphere, in the air. Another element that is important from the point of view of our firefighters is something that leads us back to those 5 or 7 tons and to the context of safe distances, or the mass of 5 tons is the key factor. There is this potentially safe zone in the context of this hydrogen station, but also in terms of such a vehicle that takes part in an accident. There are those procedures 500 to 150 meters. This is something that stems from our experience, our knowledge of having read publications and discussing with our colleagues from other countries. We know the statistics from different leakages. So the 150 meters should be a safe distance. So 150 is the distance where you have flammable substance or some threat with explosion mixed with oxygen, hydrogen may become explosive. The question is whether 150 meters is enough. Can we always evacuate people from such a big zone, depending on
Szanowni
the place
Państwo,
of the event?
informujemy, że Wasza wizyta kończy się za 15 minut. Dziękujemy, że odwiedziliście Centrum Nauki i Eksperyment. Zapraszamy ponownie.
I understood that I have to be brief. It's an announcement inviting the visitors of the experiment Center of Science to leave the building as it closes. So there are safeguards concerning certain protective measures, risk analysis, and so on. So the General Command of Firefighting, when the act was not there, it proposed a methodology of firefighting units cooperating with increased and high-risk work sites. This is for firefighters to know how to treat such work sites across Poland. So I encourage this publication to those of you who already work for increased and high-risk work sites. But there's one key element there concerning representative scenarios and catastrophic scenarios, and this cutoff. So this probability of the occurrence. As of today, we are not worried because in transport, this probability of hydrogen-related incident is far lower than the threshold. But in ADR and in the target place, so the fuel station for hydrogen, when you look at how much hydrogen will be needed, then if we take a look at a typical bus, it will need, say, between 50 to 70 kilograms of hydrogen. That's one filling up activity. The prototypical buses, or those small-scale production ones, need between 5 and 10 kilograms of hydrogen. That's just a typical car. If you take a look at a 100 tank, they do not have 200 or 300 bars, but their pressure is 40, 50 bars. But if we take regular vehicles for transporting hydrogen, they have 100, 200, 300, 400 bar. But also there are those that have much more because they even reach 700 or 800 bars. But this is still a technology that as of today is somewhat more expensive. And also owing to the construction of those containers, firefighters look at them less favorably. Those are not typical ones, composites rather than stainless steel. Those that, well, they act specifically should an incident occur. Because a metal container, it's just an image. The steel one, when it gets heated up under fire, it stays where it is. And when you have such a long and narrow shape of the vehicles transporting hydrogen, and if you think about pressure increasing there, the greatest tension is what happens in the middle of the length. So what happens is a long longitudinal crack. It can tear apart the entire cylinder, but historical incidents that took place show us that usually these containers remain unshuttered. They stay in their place. Different is the case when we talk about composite containers. Those that are used, for example, for filling up the cars, they get fragmented, they get burned through. This pressure appears in this porous mass, and they are torn apart into a few elements, and they constitute a greater threat. What we have to face as firefighters and what we are concerned about is not so much a destruction of the container itself. To withstand such a great pressure, those containers have quite a thick coat of the outer casing, but the infrastructure connecting particular containers is an element that is one of the most strategic ones, and it is at risk of getting damaged. Let's say that the vehicle turns upside down. The containers will not be shuttered, but there should be in a safe cage in order for those links between them, for the parts connecting them not to be damaged. Always in such cases, what is key is this box in which the entire fixtures set of fittings is hidden. So the firefighters should also know about the structure of such a transport. They should know what to do about it. Then they should know how to unload it in an emergency situation. if we have an unknown situation for a firefighter, then we've got the mass, maybe the vehicle is not heavy enough, but the easiest thing to do before we go about any kind of action is either burn out the medium or release it to the atmosphere. So these are the issues that we will have to handle one day. This failure rate, when we think about hydrogen, well, this is something that is usually related with the driver's mistake, if not the drivers of the vehicle transporting hydrogen, then of another driver. And usually this is the cause of incidents concerning the transportation of gases. So human error, and certainly we hope to cooperate with you when we want to get to know these vehicles better or learn about the stations. It is important that you make it possible for us so that firefighters can be educated, because without this support on your part, without you inviting firefighters to your stations, vehicles, we will not have access to this knowledge. We will not know how to get ready to take up some measures. We know that when there is a new threat appearing, usually at the central level, we get some guidelines from the headquarters. It's the same when for LPG, photovoltaic panels, and so on, with the vehicles fueled with batteries and so on. Another step will be preparing similar guidelines concerning the activities that are supposed to be taken when faced with emergency hydrogen-related incidents. Thank you very much. Could I ask you for a pointer? Ladies and gentlemen, we will wrap up the panel now within the last several minutes. I think that we offered you an overview of safety-related issues concerning the hydrogen link. We've learned we've learned about its links, and our guests shared their vast knowledge and experience. Before we wrap the panel up, let me invite you to applaud my guests. I think that we've deserved it because this panel was very rich in knowledge and information exchange. We've certainly learned a lot. I'm very happy that we had two industrial plants represented in the panel. Thank you very much for having accepted my invitation. And towards the end of the panel, I would like us to take a look at the challenges and the works to be taken up ahead. What is to be done? We've heard a lot of buzzwords. What should we do organization-wise in terms of hydrogen economy? I would briefly respond, as the summary should be short in order to be remembered. One thing is awareness. To my mind, that's the first thing that offers itself. So the awareness of investors, designers, of lawmakers concerning hydrogen. We talked before about about the fact that the simple answer does not exist. Risk analysis and individual approach is what we need. Yes, on my part, I will certainly subscribe to what we've just heard. I think that the most important element is education, trainings. Once the operators or those working at the stations already work, they should understand the process. They should have a clear idea of what's going on, what kind of changes occur, so that they are conscious about the intricacies of the process. If you don't understand the process, unfortunately, that can lead to some threatening occurrences happening. Once we've learned about the process, then I think that we should not, we should escape routine activities. I remember that when we collected samples for the first time, that was in December in our system, then the first experience we had with high pressure, with hydrogen under high pressure, initially, it raises concerns. It's your first contact, you don't know. Leak tests are performed, everything should be done, but you have this fear in you. When you do that for the second time, you don't have it anymore. So we see that the closer we are, the more we have to do with hydrogen, then the less respect we have towards such systems. And I think that that does not concern hydrogen only, but any kind of system. Because actually the risk, any substance can mean a certain risk. This is not the case that it is just hydrogen that we should all be aware of? Well, it can be threatening, but we should also remember that we often deal with more dangerous substances on a daily basis, and we somehow don't feel threatened. We do not feel any concern even when we are close to such a substance. So I think we should be reasonable. We should not overdo protective measures. As we've heard from Zdzisław, we can have a number of safeguarding solutions, but then it will learn that the investment costs grew too high, and this investment will simply not pay off. Thank you very much. Again, briefly, I will point at two elements. One is not to be afraid to use technical knowledge when there are no legal provisions in place. Our experts, those that are responsible for fire protection, they know what it means. So why not use their technical knowledge that is generally accessible? And it is there, also concerning hydrogen. Another important item from my experience is education. Education. Again, something that Paulina has mentioned. Everybody is afraid because hydrogen, that sounds scary, something magical that will explode right away. Hydrogen is not explosive, it's just flammable, but it creates an explosive mixture with the air. So it's not the worst, the most dangerous material. So educating the society is one thing, for it not to be afraid of hydrogen around, but the other thing is educating firefighters. When they go to intervene, it's good for them to know beforehand how to act. And of course, the balance here, preserving safe distances, the right number of safeguarding solutions, but also educating a firefighter, maybe not getting too deep into the phenomena, but teaching firefighters how to act based on common sense and knowledge. Thank you very much. Just don't applaud yet, I will tell you when. We haven't finished. What I've noted down is the rules of technical knowledge, so opening to the technical knowledge that is already there globally. Risk assessment, strong emphasis. Process safety, knowledge of technology, this is what we have to refer to, relating to what we've heard from Paulina. Then emergency procedures, and educating both the receivers of the technology and the firefighters and emergency service workers. So a lot is to be done technically, operationally, design-wise, construction-wise. I believe that the events like the one we are holding today, so the chat conference and other events concerning hydrogen technology, enable the exchange of experiences. So my call to you would be to make sure that we've got an increasing number of conferences focusing on the technical knowledge, that we do not cover the topic in broad terms, but focus on the details. The better we know the technology, the more we understand about the process, the greater the openness to the implementation of the technologies. Thank you very much. Thank you for your attention. I would like to thank my guests, and we invite you to continue our conversations during the breaks. Thank you very much.
Jesteśmy największą metropolią w Polsce Północnej. Jesteśmy otwarci na to, co nowe. Jesteśmy świetnym miejscem do życia. Jesteśmy Trójmiastem i dlatego zawsze będziemy dbać bardziej.
Korki na wszystkich drogach dojazdowych do Trójmiasta już dawno przekroczyły akceptowalny poziom. Dlatego samorząd województwa pomorskiego uruchomił nową linię kolejową łączącą metropolię trójmiejską z Kaszubami. Dzięki podróży pociągiem tysiące osób może szybciej i wygodniej dojechać do pracy, szkoły lub na zakupy, a potem wrócić do domu. Nie trać czasu i pieniędzy w korkach. Podróżuj szybko i wygodnie koleją. Do pracy, do szkoły, na zakupy.
So tell me what you want.